All right, we're back. So let's finish assignment 3-5 together. I think that most of the questions you can actually do first, then watch the video if you need support to see that you did it correctly. All right, so first we're going to practice differentiating some rules. So we have x cubed subtract 3x, and we have x squared subtract 4, and we're asked to take the derivative. Now, part of me feels like there's a possibility that you could factor the numerator and denominator and perhaps simplify it. Though, as I do it mentally, I realize that that's not going to be really helpful. I can factor out an x. I can go x plus 2, x minus 2, but nothing's going to simplify. So I'm going to leave it the way it is. So what derivative of rule we're going to use the way it looks? And the correct answer is you are definitely going to use the quotient rule. So that's the denominator times the, sorry about that. That's the denominator times the derivative of the numerator. Subtract the numerator times the derivative of the denominator, and then take the denominator with parentheses and square it. The quotient rule. Number 12. Now right away in number 12, I look to see that I'm going to write this a little more calculus friendly right away. So I'm going to write that as 2x subtract 1 to the half, and this one is 3x plus 1 to the 1/3. So it's important to have that algebra skill that if it's in radical form, that you can write it as a fractional exponent. And notice I also did this right here. That's going to give you a good indicator. What rule are we going to use to take the derivative? And the answer is the product rule. So what is the product rule? It's the first times the derivative of the second. So 1/3 times 1 in front, that's 1/3. Subtract 1. So the easy way is go 1 take away 3, that's negative 2/3. And take the chain rule. In other words, what's the derivative of the base? Don't forget the 3. Plus the second, 3x plus 1 to the 1/3 times the derivative of the first. That's 1/2 times 1 in front. Subtract 1 to the exponent, so 1/2 take away 1. That's negative 1/2. And then the derivative of the base, which is just 2. Yes, you could simplify it. And if this was a multiple choice, that might be helpful. But as is, in terms of how you see it, this is a great answer in terms of that. Number 13. Find an equation of the tangent line. So whenever I hear that, I want to write down what x equals, what y equals, and m equals. So I have a good, simple little template here to work from. So in the question, does it give you the x coordinate? Yes, it's 0. Does it give you the y coordinate? No, but could you solve for it? So we're going to go 3 times 0 squared plus 2 to the 4th. So 3 times 0, 0, 2 to the 4th is 16. And then the slope. Well, the slope is the derivative using the x coordinate. So before I can do that, I need to find the derivative of y. So I'm going to use the power rule and the chain rule here. So first step, 4 times 1 in front, subtract 1 from the exponent. Then what's the derivative of the base? 2 times 3 is 6, subtract 1 from the exponent. So we've used the product and chain rule here, or the chain rule and the power rule. Next, plug 0 in wherever there's x, and might be helpful to simplify. So if I plug 0 into here, I got 2 cubed. 0 here, well, wait a second. So try not to think too hard, right? Because this right there, whatever this is, it's going to be 0 times something, which is going to give the answer 0. Make sure I did it correctly. Excellent. Then, what's the equation? So we can use the template and understand the slope is 0, and then go x subtract 0 plus 16, or just simplify this to a horizontal line, which is y equals 16. So the slope of a horizontal line is 0, so that's the form that you'd likely see it in multiple choice. 14. You're given a function, f at x equals x squared plus 3 over x, and you're asked to find the average rate of change from 1 to 3. So to do that, we're going to take that interval, and that's going to be our denominator. And then our numerator is going to be f at 3 subtract f at 1. That's just the slope formula, right? Sometimes it's called the quotient or the difference quotient. We're going to plug 3 in first. That's 9 plus 3, which is 12, divided by 3. That's 4. Subtract, plug 1 in. 1 plus 4 divided by 1, that's 4 over 2. So I get 0. That's the average rate of change. Let's see if that matches my answer key. It is. The next thing you're asked for is the instantaneous rate of change. Well, the instantaneous rate of change means the derivative. It's a definition of derivative when x equals 3. So in order to do this, I need to first take the derivative here. So what rule am I going to use again is the quotient rule. That's the bottom times the derivative of the top minus the top times the derivative of the bottom. Now the derivative of the bottom is 1, so I'm not going to go times 1. That's fine. And then take the bottom and square it. Now wherever there's an x, you're going to plug in 3. So that's 3. 2 times 3. Subtract 3 squared plus 3. A lot of 3's. And then if you like, you don't have to. If you like, you can then simplify this. So 2 times 3 is 6, times 3 is 18. 9 plus 3 is 12, so it's 18 take away 12. And then 3 squared is 9. Again, you could reduce that down too if you want. Excellent. All right. Just double checking, make sure I did it correctly. Number 15. Number 15 says, what is the derivative? What is the derivative from the left, from the right, and is the function differentiable at x equals 1? So for 15, you're given a piecewise x subtract 1 cubed when x is less than or equal to 1, x subtract 1 squared when x is greater than 1. So let's just go each step at a time. So part A is, what's the derivative from the right and then from the left at 1? So the top part is from the left, the bottom part is from the right. So in order to do this, we first need to take the derivative of what we see on the top and the bottom. Notice that the chain rule would be there, but the derivative of the base is 1, so doing times 1 doesn't change anything. So there's the derivative of the piecewise. So for part A, what is the derivative at 1 as x approaches 1 from the left? So from the left, the derivative would be 0. So if you plug in, you get the answer 0. If you look at the derivative as it's from the right side, plug in 1, and 1 take a 1, 0. So 0 times 2, so it's 0. So they match. The other thing that needs to match is that it's continuous there. So if I plug in 1 at the top and 1 at the bottom, notice also the continuity there, that it is continuous. It equals the same y coordinate. So the question is part C. This is part B. Part C says, is the function differentiable at there? So we take the derivative, do they match? And then go back and also say, is it continuous? All of them go, then yes, the derivative does exist and it's 0. All right, number 16. For number 16, the piecewise is f at x equals 1/2 x squared subtract 1/2. So step 1 we're going to do is we're going to take the derivative right away. So the derivative of the top and the derivative of the bottom there. So 2 times 1/2, that's just x, subtract 1 to the exponent, and the derivative of negative 1/2 is 0. So there's the derivative at the top. Here the derivative is 1 when x is greater than 1. And so let's try this. So first of all, the derivative as x approaches 1 from the left, that's the top piece. Plug in 1, the answer is 1. That's A. For B, the derivative of x as x approaches 1 from the right. Any number you plug in will give you 1. So far so good. The left and the right agree that the derivative is 1. But, here's the but. Or let's plug it in. If I plug in 1 to the top, 1/2 take away 1/2. 0, plug 1 into the bottom, 1 take away 1, 0, so it is a continuous. Yes, So I believe the derivative does exist for number 16. Yes, it's continuous. It works. So the answer is yes. So notice I had to check continuity to know if the derivative works. Number 17. So now we have f at x equals 1/2 x squared. Subtract a half when x is less than 1. And then we have x minus 1 when x is greater than 1. Now that looks very similar to what we just did, doesn't it? Top and bottom. So what's different? You can tell the part I scratched out right here. I want you to notice that there is, it is not continuous at x equals 1. So what does that mean? It means that we have a piecewise that is defined less than 1 and one that's greater than 1. But for it to be continuous, there has to be a line under the arrow that tells me it's equal to. So does any piece here equal to 1? No. So if 1 is less than, 1's greater than. Therefore, also the derivative doesn't exist because it is there's a discontinuity there. I guess if we do it as a limit, approaching it from the left, you could do it. So if it's to be the same as what I just did for 16. So the derivative of x from the left is equal to 1, and then from the right, the derivative as x approaches 1. So that's fine, but c is no. So why is it no? Because it is not continuous at x equals 1. So it'd be a hole there. 18. F at x equals x squared subtract 2x. That's when x is less than or equal to 1. We have x squared minus 2x plus 1 when x is greater than 1. So step 1, I'm going to take the derivative of both pieces, the top piece and the bottom piece. So the top piece would be 2x subtract 2. Notice we do have one that's equal to, so that's good to see. The bottom piece would be 2x minus 2. And now let's see. So first of all, part A and then part B. So what's the derivative as x approaches 1 from the left? So here, if I plug 1 in, the answer is 0. If I take the derivative as x approaches 1 from the right, that's the bottom piece, it also gives me the answer 0. Now the last piece has to do with continuity. If I plug 1 into the numerator, I get the answer 0. If I plug 1 into the, sorry, not the numerator, but 1 into the top piece, I get 0. 1 into the bottom piece, I get positive 1. They don't match. So, does the derivative exist? No. And that we can write it as a limit and that they don't equal each other. So this is saying that the limit of the function from the left and from the right, there's a jump there. So this answer is 0 and the right answer is 1. So therefore the derivative does not exist. Now if we just look at it from the left or just look at it from the right, then we can have the derivative exist. But overall, just at 1, the derivative doesn't exist because there's a jump there. So when there's a discontinuity at an x value, the derivative would never exist. Number 19, we're almost there. See if I have enough room. So number 19 says use the limit definition to find this. So what we don't practice, of course, we forget. So I want to know the derivative of this. So this is the limit as h approaches 0. All right, I'm going to give you a chance. Press pause, and I want to see if you can remember, or maybe if you have to go back to your notes to check to see if you can see the setup to find the derivative using limits. So go for it. All right, I'm hoping that you actually tried that. So here's what it should look like. So it's this. So did we set it up this way as finding the derivative of a limit using limits? So our function in this case is x squared. So that would be x plus h squared minus x plus h. Subtract, and I'm going to use parentheses, and then you just put in the function, and that's all over h. And oh my goodness, don't do this. The limit as h approaches 0. Do not let go of your limit notation. That's not good. And you would get docked points in AP exam and so on if you start dropping your notation too early. You need to remember it. So I will remember it now. Limit as h approaches 0. Don't drop that notation. All right, let's do some algebra. Can you expand this just in your head? X plus h squared. That is x squared. You multiply the terms together and double it, and then h squared. Subtract x, subtract h, subtract x squared plus x. So be careful of your signs. Again, don't leave your limit notation. Now it's going to get much easier because we're going to start simplifying. So x squared minus x squared, h squared, negative x plus x. So all that leaves me with is 2xh, h squared minus h all over that. Now, I'm going to divide an h out of each one. And so if I divide an h out of each one and then plug in 0, we can now, it's no longer indeterminate. So now we have a 1 in the bottom. And now when you plug in 0 for h, you have 2x. And know that when you divide the h out of here, that's negative 1. So you're left with 2x minus 1. So again, I divided an h out of each one. When I divide an h here, I'm left with 2x. When I divide an h into the h squared, I'm left with h. And h into negative h, I'm left with negative 1. So when you plug in 0 for h, this is what I'm left with. And if you did the power rule, does it match? Yes, you did it. All right, I am proud of you that you did your work. Mr. G Math over and out, and until next time.